Now that you have your data ready, you've made your different data sets, you have features defined, it's finally time to actually start training your model. So, when you get to this part of the whole ML process, this is where you'll probably be writing some type of Python scripts. Maybe you're running different experiments in Conda, but whatever it is, you're more than likely working with Python, or maybe if you're doing some more, I don't know, things that need faster processing, you might work with like C++ or Rust or one of those other languages. But for the bulk of business problems, Python is extraordinarily powerful for the things that we need to predict with our ML models. So, as you dive into training your model and figuring out which algorithms to use and all the different libraries and tools you have available, let's start by talking about, well, Python and the libraries that it has to make machine learning a lot easier than it was, let's say, about 10 years ago. So you have scikit-learn, you have TensorFlow, which is hugely powerful, you have PyTorch and Keras. So these are some commonly used machine learning libraries that you'll see in Python projects quite a bit. So regardless of whether you're working with Python scripts directly, or again, maybe you're breaking it down into steps in a Conda file, or maybe you're even using something like Google Colab, if that's still around. But these are just some of the libraries or the packages that you'll run into as you work with different teams. So the way that you decide which of these libraries you actually use for your project, it's gonna depend on your data and the algorithms that you want to experiment with. So a lot of the libraries have some common functionality, like all of them have some kind of neural net functionality, all of them have some kind of random forest classifier, and some of the more common algorithms like k-means and things like that. So what it comes down to a lot of times is really the data drives the decision, and of course just developer preference. So none of the libraries are right, none of them are wrong. It just depends on what kind of data you're working with, and maybe which of the libraries will give you a little bit more performance. So maybe one of them will run a little bit faster than the other, but when you're trying to run hundreds to thousands of experiments, a little bit faster, hundreds of or thousands of times, is a lot of time that you save. So as you're looking through your data, it doesn't hurt to kind of start looking through the different libraries that you have available too, and start really thinking about which algorithms would fit your data set the best. So if you're doing some kind of clustering, maybe you look at k-means. If you're doing just like a binary type classification, you might look at maybe something more simple like linear regression, or really anything that will maybe give you the results you're looking for. Again, you don't have to know this off the top of your head going in, but having a little intuition behind when you would use each algorithm based on the data sets that you have available, it'll just save you a little bit of time. But again, you're experimenting, so it's okay to cast a pretty wide net at first and tighten it up quickly. So once you've picked your machine learning library, there are some other libraries that are just really commonly used in Python, whether it's for data engineering, data analysis, or machine learning. You'll likely almost always see these three libraries, especially the last two. NumPy and Pandas are indispensable for any type of machine learning project. That's how we manipulate the data and get it into the format we need to work with the machine learning libraries, or do really any type of data manipulation we need and do it quickly. So these are some that, of course, if you've been doing machine learning for a while, you definitely know about these. And if you want to get more depth on some of the functionality you have available, I always suggest just go check out their docs and start playing around with the methods and parameters that they have. So one of the things you might do when you're starting out your model experimentation journey, start by making some kind of template for your model experiments. So there's some common things that you'll need regardless of what experiment you're running. There'll probably be some data, like you'll need to know which data set you're using. You'll probably have some type of hyperparameters, and we'll talk about those a little bit later in the lesson. But you'll probably have some kind of hyperparameters. You might have some other different configs that you try out just based on the algorithm that you're using. So there's some just kind of standard input that you might start to notice over time as you build your model and go through several experiments. So when you start to notice these trends and arguments that you need to pass in order to train your model, start developing those templates early and go ahead and get them into version control so that you can keep a record of kind of what you were thinking at the time. So let's take a switch and look at an example of some model experiments. So now we're in VS Code and we're going to take a look at two examples of potential templates for an experiment. This first one that we're looking at, you'll notice this is just a Python script. We've imported a few different packages, and you'll see good old NumPy and sklearn. We're using a random forest classifier algorithm in here. And you'll notice that we are getting some parameters from some YAML file. We'll talk about this a little bit more when we get into experiment tracking, which will come up later in this lesson. But in this instance, we know that we're going to get some parameters from a file. There's 3 different arguments we're expecting in order for this script to run, and we have some training set input here, and then we go ahead and actually train our model. So what we have now is where we've pulled in those parameters. These are going to be hyperparameters that we use to tune the algorithm and try to get the best performance out of our model possible. And then at the end, you see we dump our model and into this pickle file. So that's what we're doing in this model experiment. Then we have another one over here. This one is a lot simpler just because you'll see what we use it for a little bit later in this lesson when we're talking about experiment tracking. But this one, you see we pull in some data, we split it into our train and test sets, and then we make a model, and then we train the model, and then we get some predictions out. So both of these are different types of templates you can create, and you'll notice you can just change the data sets, you can change these parameters in here, you can even change like the output that you want. So we've taken a look at a couple of ways to write experiments. So let's go on and see what it's like to start getting deeper into our model experimentation.